In this video, I would like you to look at some problems to solve where your knowledge of how to differentiate a function of a function will be useful. For example, we need to find the equation of the tangent and the normal to the curve y equals 5 over x squared minus 3 at the point 2, 5. First of all, let's just simply to ensure that indeed this point is on the curve. So if x is 2, y is going to be 5 over 2 squared minus 3, which is 5 over 2 squared is 4, 4 minus 3 is 1, so I have 5. Indeed, this point is on the curve. So now, let's write our equation for the curve in the index form. So I have 5 over x squared minus 3, and now I will write it in the index form as 5 times x squared minus 3 to the power of minus 1. Now we need to find the tangent, we need to know the gradient. The formula for finding the equation of a line is y minus y1 over, equals, gradient m times x minus x1. How can we find the gradient m? M is going to be dy by dx at that particular point where x is 2. That means I'm going to find the derivative of y with respect to x at the point where x equals 2. Alright, so now to be able to find the equation, everything what we need to find the gradient first of all. Alright, so we'll do dy by dx, which is, we notice it is a function of another function, so we need to apply the chain rule, dy by du times du by dx. Okay, so let's find our u. So our u is going to be x squared minus 3, then y is going to be 5u to the power of minus 1. Alright, now we need to find du by dx and dy by du. Du by dx is 2x, dy by du is minus 5u to the power of minus 2. So now we need to find dy by dx. Dy by dx is going to be dy by du, which is minus 5, u is x squared minus 3 to the power of minus 2 times 2x, which is minus 10x x squared minus 3 to the power of minus 2. So now we need to find the value of this derivative at the point where x equals 2. So m is equal minus 10 times 2 times 2 squared is 4 minus 3 to the power of minus 2. And I would say 4 minus 3 is 1. 1 to any power is 1. So minus 10 times 2 is minus 20. Our gradient is minus 20. Our point is 2, 5. So we're using all details that we have to get the equation I will be writing here. Y minus y1 is 5 equals minus 20 times x minus x1, which is 2. Okay, so and let's open the brackets. Y minus 5 equals minus 20x plus 40. It's because minus 20 times minus 2 is positive 40. And now let's just polish our solution. Minus 20x, adding 5 to both sides, getting us plus minus 20x plus 45. Or if we are not happy, and obviously we shouldn't be happy with the negative gradient, so we can write our equation as 20x plus y minus 45 equals 0. This way, or just equals 45, 20x plus y equals 45. Here's the solution, the equation for the tangent. Now we need to find the normal. To find the normal, we need to remember that the gradient of the tangent was minus 20. So the gradient of the normal, that doesn't look like the gradient of the normal is going to be negative reciprocal of the gradient of the tangent, which is minus 20. So our gradient is going to be 20. The same point as previously, so 2, 5. So we now we need to find the equation of the line. Y minus y1 equals mx minus x1. So we have y minus 5 at the same point. M is 1 over 20. X minus 2. And opening the brackets gives us minus 1 over 10. Perhaps we could do better if you notice that we have our gradient as a fraction. So, and we don't like to have any fractions in our equations for lines. So I should multiply actually by 20 immediately. So I should get 20y minus 100 equals x minus 2. And now we'll tidy up. 20y equals x plus 98, and we could leave it as it is, or we can write this as minus x plus 20y minus 98 equals 0. Any of these two would be fine. Alright, and now let's see how you could do it on your own. Here's the same question. You need to find the equations of the tangent and the normal to the following curves at the given points. Try on your own and then pause the video before I will release the answers. Now you can see the answers for the tangents and for the normal. Bring your solutions to the class and we'll discuss together. Thank you for watching.